Here we go. Hey! It is time for Earth Science Chemistry. We're talking about the combination of atoms. 8.2 in your notes if you're following along at the Play at Home game. So we're going to go over our objectives first and kind of go over what we expect you to know by the end of this. So number one objective, explain how atoms join together and form compounds. Number two, describe ways that electrons form chemical bonds between atoms. Number three, read and interpret chemical formulas. And then number four, explain the difference between compounds and mixtures. All right, so first things first. A compound is two or more elements combined. Name a compound. You drink it every day. How about water? H2O, right? When we say H2O, what does H2O mean? It's two hydrogens and one oxygen. H2O. Now, when we draw this out, the little 2 is underneath. It's called subscript. I'll show you that in a little bit. Here it is. So, if you look in this diagram right here, hydrogen has a little subscript. That means there's two hydrogens. O doesn't. That means there's only one of them. Now, interestingly enough, when we look at our chemical symbols, Na, capital N, little a, that says, hey, that's an element, sodium. C, capital C, little L, that's chlorine. There's two things there because there's no subscription, there's no numbers in front of the whole thing. So we have sodium chloride. There are two atoms. One is a sodium, one is a chlorine. The next one, CO2, same thing. This subscript right here, this 2, means there are two oxygens. There's one carbon. If we were to put a number in front of the whole thing, so I've put like 2 CO2, that means there would be now 2 carbons and 4 oxygens. We would simply multiply. What's a molecule? A molecule is the smallest unit of that compound. So if I say, hey, what is a molecule of water? If we can get water down to the fundamental elemental drops of 2 hydrogens and an oxygen, that would be a molecule of water. Diatomic. What does di mean? Be careful here. Di means 2. Doesn't mean that you're going to kill somebody, right? Diatomic. What's atomic mean? Atom. Diatomic, 2 atoms or 2 atom molecule means that we have 2 atoms normally. Now there's a couple of them that do it normally. So one of the ones is oxygen, O2. Another one would be hydrogen, H2. So when we look at these, N2, nitrogen, F2, be careful how you say that. So if you look at the diatomic molecules, Cl2, Br2, I2, At2, right? It forms a 7 up there. They're called the diatomic molecules on your periodic table. So here's a good image of water, right? So you got the big fat hot oxygen sitting right here, and you got 2 hydrogens hooked up connected to it, right? Diatomic. In this picture, there are 1, 2, 3, 4, 5 molecules of water. Now the reality is this. I don't know what this stuff is behind there. Maybe it's a cloud. I don't know. I don't know what that is. But there's 5 molecules on the picture. All right, electrons and energy levels. So here's the deal. Electrons are really easy if you think about it. And what I'll do is I'll kind of walk you through it. The other day we learned that electrons equal protons in a neutral atom. I'll say this again. Electrons equal protons in a neutral atom. All right, so we're going to just deal with neutral atoms right now. All right. So what happens is if we look at our periodic table chart, how many how many electrons would hydrogen have? Well, it has 1, right? Because the atomic number of hydrogen is 1, top left-hand side. Okay? If we look at helium, helium has 2 electrons. It has an atomic number of 2. It's the one in the upper right-hand corner. If you guys want to follow along, it's on page 143 and 144 of your book. And you can see the atomic number. So helium has 2. Now, if you look at the periodic table up there, you see that it has rows going across. And hydrogen and helium are in the same row, even though they're separated by a bunch of elements. Do you guys see that? You see it on your periodic table? Okay. So, looking at this, that top orbital or that top line can only hold 2 electrons. Why? Because you got 1 in the first column, and on the very far right, it's got the second one. So, in level 1, or the first level around your atom, it can only hold 2 electrons. Now, here we're going to guess on what the next level is. Don't look at the screen. Take a look at your periodic table and look at row 2. It says 3, 4, 5, 6, 7, 8, 9, 10. So it's lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Do you see that? Okay. So here's my question. Just guess how many electrons that row can hold. No idea? Can you count? Take a look at it. I just said the first row holds 2. 1, 2. How many do you think the next row can hold? What'd you say? 8? Yeah, you're right. 8. So 8 electrons in the next one. Anybody tied? Take a look at this one. Here we go. Anybody want to guess the next one? Starting with sodium. You got to turn around. Here we go. Take a look at the periodic table. Sodium, magnesium, 11, 12, aluminum, silicon, 13, 14, phosphorus, sulfur, chlorine, 15, 16, 17, and argon is 18. Anybody want to guess? Anybody want to guess how many that row can hold? 8. That's right. Wow, you guys are getting it. So now we do a little bit of a different thing here, okay? And we're going to the next row. Now, before I do, I want to show you a little trick. You'll have to excuse me. I normally have this at any time ready to go. And so this next one I call my House of Pain rule.
If you love shrimp like I love shrimp, come to Red Lobster's Endless Shrimp for as much as you want, any way you want it. Sweet, buttery, and creamy. Like new pineapple habanero coconut shrimp bites and teriyaki grilled shrimp.
The House of Pain rule
it won't last forever.
Is one of my favorite. Here we go. And you'll understand. You'll understand. Make it full screen here.
The House of Pain is in effect.
There we go. Here we go. Pack it up, pack it up. Let me begin. The electrons jump around again. Let jump around. Jump around.
Let me begin. I came to win, battle me, that's a sin. I won't ever slack up. Punky better back up. Try and play a role and you're the whole crew will act up.
So the House of Pain rule, what does it mean? Well, the electrons, by the way, you guys can clap on that. Go ahead, clap. Thank you. Right? Jump around, jump up, and get down. Right? So here's what happens. Take a look at your periodic table. Potassium is 19. All right? So potassium is 19. It's in the fourth row. Calcium is 20. All right? And so what happens is you'll note that there's a big gap there. And it goes 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay? Those guys all get excited and they do the House of Pain rule. So what I'm going to do is I'm going to draw these out, I think, I can do that. I've got markers somewhere. So I'll use this here. Here we go. And I'll just do this. Here we go. So I'm going to do, let's do potassium. So we have 1, 2, that's hydrogen and helium's electrons. The next row holds 8, we said. So that's lithium, beryllium, boron, carbon. These are supposed to be electrons. Not very good. Nitrogen, oxygen, fluorine, and then neon. So there should be 2 in the first shell, 8 in the second shell. Here we go to the next one. So then we have sodium, magnesium, then aluminum, silicon, phosphorus, sulfur, and then chlorine, and then aluminum. I'm sorry, argon. It's crazy. Here we go. Here's the next one. So here comes the House of Pain rule. So we have potassium, which is number 19. We have calcium, which is number 20. And then they House of Pain on us a little bit.
Get up, stand up, come on, throw your hands up if you got the feeling. Jump up, touch the ceiling,
jump up and get down, right? And so what happens is number 21 comes up here to the inner level. It jumps up. And then 22 titanium jumps up. 23 vanadium jumps up. 24 chromium jumps up. 25 manganese jumps up. Or is that magnesium? I can't see. No, it's manganese. I was right. And then iron jumps up. And then cobalt, nickel, copper. I'm just putting them in here. Zinc. Now we're back at the same level. 31, gallium. 32, germanium. 33, arsenic. 34, selenium. 35, bromine. And then 36, krypton. Now there should be 8 in the outer shell. 1, 2, 3, 4, 5, 6, 7, 8. So basically, all of the ones from 21 down to 89 and 30 down to 112 in the middle of the periodic table, they all House of Pain. Jump up, and stinking get down. Right? Hey, by the way, I don't know if you guys know this or not. This is actually not the real name for that. I invented that name, and so if you use this in terms with PhD candidates or things like that, they're probably not going to recognize the House of Pain rule, but that's really what it is. And so from now on, I'm thinking about publishing that. Okay. So House of Pain. We call those energy levels. All right, a chemical bond. Chemical bonding. What's holding atoms together within a compound? Okay? I tell you what we're going to do is talk a little bit about this just so you understand chemical bonds, and then we're going to work on the House of Pain rule and electrons. All right, here we go. Chemical bond. Anything that's holding an atom together within a compound. All right? So basically, electrons are going back and forth. They're being either shared or given away. The first bond that we talk about is called an ionic bond. A little too ionic. Yes, I really do think. You guys are too young to know that. I believe that's Alanis Morissette. But anyhow, ionic bond, electrons are given away. They are transferred from one to another. So when we have the compound that is made out of multiple elements formed, basically it's called an ionic compound, right? If it's an ionic bond, we have transferred the electrons. Now, where does this occur between a metal and a non-metal? We'll discuss that in a little bit here. That electron that has been moved is called an ion. Now, to make you understand or let you understand this, electrons are what? Positive or negative? Do you guys remember? Electrons. They're negative. That's right. So if they're negative, that means if I lose an electron, it becomes more positive. So when an electron goes away, it becomes a positively charged ion. And when an electron is gained, it becomes a negatively charged ion. So for example, in this particular instance, sodium has 11 electrons but 1 in the outer shell. It wants to give it up. So it becomes a positive ion or a cation. Now here's the cool way of memorizing this, right? My cat is always running around and just a happy playing. I don't know if he got into catnip or what the deal is, but he's always running around, jumping, happy, killing mice, but happy. Not so good for the mice. He's a happy cat, so it is a cation when it becomes positive. And an anion, my aunt is always negative. She always says things about me, right? She always says I need to learn and grow up and things like that, so she's always negative. It is an anion. An anion. A cation and an anion. So if we look at this ionic bond right here, right? So sodium wants to get rid of the electron to chlorine. And so what happens is we have a positive 1 charge, we have a negative 1 charge. This is an ionic compound. An ionic compound. Again, just a different way of looking at it. And what I like about this drawing here is you can see the electrons. So let's look at sodium. 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 is right up here. It's the top one. But it's not happy. It wants to get to a stable state. We'll talk about octets in a little bit. It transfers the electron to chlorine, who has 17 electrons. It wants 1 more. Now, ultimately, all the electrons want to get to that very last red column. They want to be stable, right? And that's the noble gases: helium, neon, argon, krypton, xenon, radon. Okay, so what we've done today so far is we've discussed how they join together, and we've started the chemical bonding. We've discussed one-way ionic bonding. Okay? So what we're going to do is we're going to stop there. This is part 1 of this series on bonding. I hope you guys enjoyed it, and have a great day.